Hello there, this is the video for our PIA of Mathematics 1 of Alondra, Flores, Peña, Alejandro, Castillo, Mercado, Juan, José, Rodríguez, and Luis Diego González Vargas. Firstly, it's important to say that the criteria of the first and second derivative are very important tools to let us know the behavior of a function without having a graph. Here is the function that we will be analyzing. And then to apply the first derivative criteria, we have to derivate the original function. And the first points that we're going to be obtaining are the critical points that are the values of x when the first derivative is equal to 0. In this case, we had a quadratic equation, so we will be using the general formula to obtain the values of x, that is x1 equal to minus 0.534, and the second one is 0.312. To obtain the maximum and minimum points, that are the maximum is the highest point on a mountain and the minimum point is the lowest point on a valley of the front and on the function, and only be ubicated over critical points. In this case, we have two critical points, so we have to substitute the value of x in the original formula to obtain the values of j. And here we have the two coordinates of the 2 points that are the same critical points and maximum and minimum points. Then we have to obtain the intervals in which the function will increase or decrease. Firstly, we have to establish the intervals with the values of x of the critical points. And firstly, we have minus infinite to minus 0.534. The second one will be minus 0.534 to 0.312. And the third one will be 0.312 to infinite. We have to choose a test value that will be a value between the value of the intervals, and this test value will be substituted on the first derivative equation. What we're going to take on account will be the sign of the result. If it's negative, the function will decrease, and if it's positive, the function will increase. So in the first one, the function decrease, in the second one will increase, and in the third one will decrease. Then pass to the second derivative criteria, we have to derivate our first derivative equation to obtain the second derivative equation. We have to obtain the inflection points, that are the points that indicate us a change of concavity. And to obtain us, we have to obtain the value of x when the second derivative is equal to 0. So in this case, we only had to clear the variable of x, and the result of x will be minus 1 over 9. This result, to obtain the j value, is important to substitute it in the original formula to obtain the j variable. So then here we have the coordinates in fractions and then transform it to decimal. And as we had done on the increase and decrease intervals, we have to make concavity intervals taking on account the inflection point value on x. So the intervals will be minus infinite to minus 0.11 and minus 0.11 to infinite. Also, we have to get a test value that will be a value between the interval, and this test value will be substituted on the second derivative formula. Also, we only have to take on account the sign of the results. So if it's positive, will be a positive concavity, and if it's negative, we will have a negative concavity. So in the first case, we have a positive concavity or the concavity up to the top, and in the second one, we will have a negative concavity or that goes downwards. So to evaluate and confirm our results, we put our function in a software. So here is the real graph, and there are our important points marked. We have the minimum and maximum points, and in the middle is the inflection point. So the interval before the inflection points, we confirm that our concavity is positive, and after the inflection point, the concavity is negative. Between the maximum and minimum points, we have a increase on the function, and between the minus infinite to our minimum point, we have a decrease on our function, also with the maximum point till infinite, we have a decrease on our function. So these are all of our results in this function. Thank you for your attention.